Good morning everyone. Welcome to today's lecture on nano basics. In this session, we will explore the fundamentals of nanotechnology, understand the significance of the nanoscale, discuss different types of nanomaterials, learn about fabrication approaches and examine the important applications of nanotechnology. This presentation is organized into two major sections. The first section introduces nanotechnology, nanomaterials, their characteristics, history and fabrication approaches. The second section focuses on the applications of nanotechnology in medicine, communication, industry, consumer products and environmental protection. So let's discuss what is nanotechnology. Nanotechnology involves the design, characterization and applications of materials, devices and systems by controlling the matter at the nanometer scale. A nanometer is 1 billionth of a meter. By manipulating the materials at the atomic and molecular levels, scientists can create products with unique and enhanced properties compared to the conventional materials. Why nanoscale? Why are researchers interested in the nanoscale? At dimensions between 1 and 100 nanometers, materials exhibit significantly different physical, chemical, electrical and optical properties. These unique behaviors arise because of quantum effects and the interested surface area to the volume ratio. Next one is why nanoscale? The visual comparison. This slide illustrates the relative size of the nanoscale objects compared to familiar objects. To put it into perspective, a human hair is approximately 8000 nanometers wide. As materials become smaller, their approaches properties change dramatically, enabling innovative applications across many fields. What is nanomaterial? A nanomaterial is any material that exhibits unique properties because of its nanoscale structure. Nanomaterials are formed through the incorporation or organization of nanoparticles. Examples include nanocrystals, nanopowders and nanotubes. Next one is carbon nanotubes. This slide shows the carbon nanotubes. Carbon nanotubes are cylindrical structures composed of entirely of carbon atoms. These possess exceptional strength, low weight and excellent electrical conductivity. These properties make them useful in electronics, sensors, batteries and advanced composite materials. Next one is noble metal nanocrystals. Here we see the noble nanocrystals with cyclic pentatwinned structures. These nanocrystals are commonly made from metals such as gold, silver and platinum. They exhibit unique optical and cathodic properties and are widely used in biomedical applications, sensors and crystals. Next one is nanopowder. Nanopowders consist of particles with dimension in the nanometer range. Due to their extremely high surface area, nanopowders shows increased reactivity and improved performance. They are widely used in coatings, batteries, catalysts, ceramics and other applications. Next one is the properties and applications of nanotubes. Nanotubes are extremely strong mechanically and very pure conductors of electronic circuit. These carbon nanotubes are mechanically strong and excellent conductors of electricity. Their applications include electronic components such as resistor, capacitor, inductors, diodes and transistors. They are also used in energy storage devices and flexible electronic systems. Next one is the unique properties of nanomaterials. Nanomaterials exhibit fundamentally different properties compared to bulk materials. The primary reason is their high surface area to volume ratio. As more atoms are exposed on the surface, materials becomes more reactive and demonstrate enhanced mechanical, thermal and electrical properties. Next one is increased reactivity at the nanoscale. One important consequence of nanoscale dimensions is increased in interaction and reactivity. This means smaller amounts of materials can achieve better performance. The properties of materials at the nanoscale can differ significantly from those of the same material in bulk form. Next one is nanomaterial characteristics. Most nanomaterials are considered novel because they possess characteristics different from their conventional counterparts. Nanomaterials can be classified according to the number of dimensions that exist within the nanoscale range. Next one is the category of nanomaterials. Nanomaterials are characterized into one-dimensional, two-dimensional and three-dimensional structures. One-dimensional nanomaterials include thin films and surface coatings. Two-dimensional nanomaterials include nanowires, nanofibers and nanotubes. Three-dimensional nanomaterials include nanoparticles, colloids, quantum dots and nanocrystalline materials. Next, when did nanotechnology started? Although nanotechnology appears to be a modern field, its roots extend back several decades. Scientists have been creating nanoscale structures such as polymers and semiconductor components for many years. However, recent technology advancements have accelerated their growth of nanosciences. Next one is the development of nanotechnology. The development of advanced instruments such as electron microscopes and atomic force microscope has enabled researchers to observe and manipulate matter at the atomic level. These tools have played a critical role in expansion of nanotechnology. Next, approaches of nanotechnology. There are two primary approaches used in nanotechnology fabrication. There are top-down approach and the bottom-up approach. Both approaches aim to create nanoscale materials and devices, but they use different methods. Top-down and bottom-up approaches. In top-down approach, larger materials are reduced to nanoscale dimension using techniques such as cutting, milling and lithography. In the bottom-up approach, atoms and molecules are assembled to form larger structures through chemical synthesis and self-assembly. Each approach has its own advantages and disadvantages. Examples of fabrication techniques. Examples of top-down methods include photolithography and inkjet printing. Examples of bottom-up methods include chemical synthesis, self-assembly and potential assembly. The choice of method depends on the desired application and required material properties. Next one is applications of nanotechnology. Nanotechnology has applications in many sectors including medicine, information technology, heavy industry, consumer products and environmental protection. Its ability to enhance material properties has made it an important field for innovation. The environmental application. Nanotechnology contributes significantly to environmental sustainability. Applications include carbon capture, pollutant sensor, decontamination, wastewater treatment, energy efficient materials and drinking water purification. These technologies help address critical global challenges related to clean energy and environmental protection. Thank you.